Hello, this is Math 1115, Alternative Delivery for April 6th, and this is part one of several parts. This part includes the Chapter 2 quiz solution and leading off with a COVID-19 reset. As always, have your pencil and paper ready and be prepared to pause and restart this video. I want to open by reminding you that we can do this and we remain flexible. Teaching and learning can continue unabated. Grades can be earned and rendered, and educational goals need not be deferred. I encourage you to stay the course. But things change. And as my wife, a quilter, when she made this said, when life gives you scraps, make quilts. That's what we're doing. But John and I are well prepared to give you the best course possible, and in fact a fine course in an absolute sense. So we're resetting after spring break. Grades for this Chapter 2 quiz and other elements of your grades have been posted, and going forward accommodations abound. This may be, for some of you, your best opportunity yet to get this course requirement behind you. I am going to include Chapter 2 content on the final exam that we will be having, even though many of you did not take it. And I've changed my mind because now it is clear we're not coming back this term, so there will be a final exam online during our final exam period. More about that later. And as originally planned, it will count for 1/3 of your grade, so please stay engaged as we go forward towards that conclusion of the course. I have decided to count Quiz 2 as extra credit for those who took it. That's good news for them, and it's not bad news for anyone else. I originally was going to have people take it when we returned, but now we're not returning. So this is the solution overview. There will be more reset continued in other videos. Problem number 1. We were to consider the following figure and complete the table. AB was parallel to CD. We were to find these angles. The first angle is this one right here, and those are parallel lines, and we're on the same side of the transversal, so those are supplementary. So this has to be 32. AFG is this one. That symbol means it's 90 degrees. DGH is here. That is a vertical angle with the one we found to be 32, so it is also 32. EGI. EGI is going to be 32 plus 90, or 122, and CGH is going to be, now you want to be careful here because this is vertical with this one, and that means that that is going to be 58 degrees, so that is 90 and 58, and that adds up to 148. That's problem 1. Problem 2, we consider the figure with this CT being a tangent to the circle centered at O, and this arc AB has measure of 50 degrees as shown. And so BTA, this angle right here, is an interior angle, so it has 1/2 the measure of the intercepted arc, or 25. BTC, we know that the tangent is perpendicular to the radius drawn to the point of tangency, so that has to be complementary with the 25 degree angle we just found. That is 65. TAB is this angle right here. That again is an interior angle, so it's 1/2 the measure of the intercepted arc. The intercepted arc is 130, so this has to be 65. ABT. ABT is this angle that intercepts a diameter. So that's going to be half of 180 or 90 degrees. And BOT, again you had to draw that, but that's what's called a central angle that's equal to the measure of the intercepted arc, or it is 130. Here we have a person's eyes were 160 centimeters above the ground, and they're looking into a mirror. And physics tells us that this angle is the same as this angle, and that means those are right triangles, and that means that they're similar triangles, so the proportionalities work. So if we were to call this distance x, we would have 160 over 120 is equal to x over 4.5. So that is x is equal to 6, and you do need to include units for full credit, so that is 6 meters. We have a rectangular soccer field. The width is 70, but the diagonal is 130, so we have to use Pythagorean Theorem to find the missing side length, and that's going to be this number, and we'll round that to 110. So the perimeter is, we're adding the 110 and 70 and multiplying by 2. That's going to be 360, and the units should be yards. And then when we have both sides of the rectangle, the length and the width, we can multiply them together to get the area. That's going to be 7,700 square yards. The Bermuda Triangle is an equilateral triangle, and each side is 1,600 meters. So we're going to use Hero's formula. The semi-perimeter can be found to be 2,400 kilometers. So we plug that and the lengths of the sides into Hero's formula, which was given in the grace notes, and do the calculation, and our answer should be 1,100,000 square kilometers. The radius of this quarter circle is 5, so this side is 5 and this side is 5. We're to find the area of this shaded area, and it's a quarter of a circle, so the area of the big sector, in fact, is going to be 1/4 pi r squared. And we're going to subtract off the area of this triangle. It's an isosceles triangle of side 5, so it's 1/2 times 5 squared. And we do the arithmetic, and we get the final answer should be 7.13 square inches. Here we're to consider the irregular shape shown, and there's the measurements. The measurements are in meters. That tells us what unit to have. And this is a setup. I in fact told you to use the trapezoidal rule, which was in the grace notes. And so what we have to do is use the trapezoidal rule formula. Each of those is 8 meters, so it's 8 over 2, 0. All of these are multiplied by 2. And then we add the final one, and we do the calculation, and we get 66.8 meters. In a practice mission, a ladder is extended 10 feet just to reach the bottom of a 2.5 foot high window, and the foot of the ladder is 6 feet from the wall. To what length must the ladder be extended to reach the top of the window if the foot of the ladder remains 6 feet from the wall and cannot be moved? Okay, so we take the length of the ladder to be 10 and the base to be 6, and that tells us that the remaining side is found by the Pythagorean Theorem to be 8. We add 2.5 to get us to the top of the window, and now we have a different triangle, and so we can use the Pythagorean Theorem differently to find that the length of the new ladder is going to be 12.1, and the unit should be feet. Here we have a circular pool, 12 meters in diameter. It is important for you to realize that's diameter because we're going to be using 6, and has a circular sitting ledge which is 0.6 meters wide around it. It's uniformly 0.6 meters around it. A a picture could probably help you. We want to find out what is the area of this ledge. Well, what we're going to do is we're going to take the radius of the big circle and minus the radius of the radius of the big circle squared. We're taking the difference in area. So including the ledge, the radius is going to be 6.6 meters, and so the area is going to be pi times 6.6 whole squared, and we're going to subtract pi, and then it's r squared, which is 6 squared, and we're going to get 23.75, and the answer should be square meters. Here we have a couple of parking lots shown in the figure. We're finding the area of both parking lots A and B, and we tell you the frontage lot A has on Main Street and the frontage that B has on Main Street, and we also tell you the boundary between the lots is 120. So these are the frontages. There's the boundary. We have to find the remaining side, and the triangles are similar, so h over the sum of those two sides is the same as 120 over 140. So we can solve for h, and we get h is 192. And then we find the area. Now we then have the area of A is going to be 1/2 the base times the height because it's a triangle. The area of lot B is going to be the formula for the area of a trapezoid. We get 8,400 square feet and 13,100 square feet. Here we have a paper cup in the shape of a cone as shown, and we're asking what area of paper stock needs to be used to make this cone. That's going to be the surface area of the cone, not including the top, because the cone is open at the top so you can drink from it. And so we just use our formulas. So h, the height of this is going to be 3.5. We need the radius, so the radius is half of the diameter, so it's 1.8. And we use the Pythagorean Theorem to find the slant height, because we need the slant height in the formula. So the slant height is found to be 3.9357, and then we use the formula for the surface area, pi r times the slant height, and we get it as 22.3, and the unit should be square inches. The final problem is a volume problem. We have a hot water tank in the shape of a right circular cylinder, and we have a hemisphere at the top, and we ask how many gallons can the tank hold. And I do give you the conversion factor here, that a cubic foot is 7.48 gallons in this case. Okay, so the volume is going to be the volume of the cylinder and the volume of the dome. The volume of the dome is half of a hemisphere, so we get this. And the height of the cylinder, I gave you the total height, is going to be the total height, but we subtract off the radius of the hemisphere because we don't have that as the cylinder part. So the radius is going to be 1.25. So we have all of the numbers that we need, and the formulas were in the grace notes. So we do that calculation, and we get this is the volume, which is 21.2712 cubic feet, and then we have to change cubic feet to gallons using this, and that's gallons per cubic feet, and so we get 159 gallons rounded off. Now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. Take care.